Hello, everyone. My name is Rick, and also from my part, a very warm welcome to this Hopsworks webinar. This is a webinar that is part of a series of webinars, which we're doing almost every month now, about how Hopsworks can add value to specific businesses, to specific government organizations, obviously, to specific industries, right? And so today, the topic is actually a super interesting one and one that we cherish here at Hopsworks, which is the fact that we believe that there's quite a bit of potential and quite a bit of value to be had by government organizations and specifically law enforcement organizations by leveraging some of the tools that Hopsworks provides. So hence this webinar, and I'll be taking you through some slides here, but also hopefully spending a little bit of time showing you some of our product capabilities so that you can hopefully be a little bit inspired to take the next step and try this out for yourself. Right, so the topic is pretty clear. We're going to talk about sovereign AI and specifically law enforcement. I might extend this a little bit and talk about how this adds value for lots of different government organizations. I think some of the techniques here are quite generic and can be applied to different organizations at large. So I want to start this webinar by talking a little bit about the state that we are in, as an industry, a software industry, a machine learning industry, and an AI industry, right? So obviously these things are related. And I think it's pretty obvious that, ever since people started to use some of the more popular generative AI tools out there, ChatGPTs, the co-pilots, the deep seeks, maybe even, when we started to use all of these types of tools, it became pretty clear that machine learning and AI are extremely powerful. We're starting to see here, and it's undeniable that machines are really good at some particular types of processes of large amounts of static, batch, or real-time data, right? The tools have become so good, right? We can make sense of some of the most complicated data sets out there, specifically language or video or whatever it might be. So we probably can also do that for other data sets. We can see these patterns. We can leverage these patterns to make really solid and operational predictions really, really well these days. So as a consequence, I think everyone is kind of seeing the value. Everyone is assuming that they can use these tools to generate useful output for their organization. But there is a but, right? And that but is, first of all, there because of the complexity of implementing these tools and implementing these systems, right? First of all, obviously, we all know that the data integration, the ecosystem integration complexity is massive, right? There are so many sources of data out there, right? There are so many different cadences that we need to integrate that data with, and so many types and schemas that we need to align in order to be in a position that we can start the process of machine learning and AI, right? So the integration complexity is massive, right? At the same time, the variety of the different tools, the complexity of the engineering knowledge that you need to have in order to bring these tools together has also exploded, right? So there's a lot of different pieces here, a lot of different moving parts that in order to do this in a production ready way, you kind of need to know them. You kind of need to be a master of them. And as a consequence, there's a lot of knowledge that you need to gather. There's a lot of competencies that you need to gather in order to deal with this complexity. And then operationally, obviously, if you want to use machine learning and AI in production, well, that has its own challenges. How do you do that? How do you run these large clusters of, high performance computing capabilities in production 24 by 7, like, our users, our customers, our citizens expect, right? How do you do that? Right? isn't always that clear, right? And I think some of this has to do with the fact that the processes with which we build these systems are quite complicated as well, right? In order to do AI, in order to build a machine learning system, there are quite a few steps involved. At Hopsworks, we like talking about FTI pipelines, right? Feature engineering pipelines, um, um, model training pipelines, and then inferencing pipelines, FTI, right? And these pipelines need to be automated. They need to be run, continuously and automatically, right? So I think, there's some process complexity to this as well. And of course, there are organizational complexities, right? Because very often these process responsibilities are actually split across different teams. Data engineers do the feature engineering, right? Data scientists actually build the model and test the model. The machine learning engineer puts it into production, starts serving the model and starts monitoring the model. And all of this, obviously, and especially in a government and a law enforcement context, needs to be overseen. There needs to be some architecture to it. There needs to be some governance to it. So it's pretty clear that we're, not only dealing with integration complexity, operational complexity, engineering complexity, process complexity, team complexity, and then obviously also financial complexity. Who's going to pay for all this? Right? This doesn't come cheap. There's a lot of costs involved, both, from buying the infrastructure or renting the infrastructure. We all know what the price of a GPU is these days, and it's not cheap. To, just making sure that we can afford this, not just in testing, but also in production, right? It's expensive. It can be expensive, right? So as a consequence, more questions are piling up here. So what we believe is that we actually need to build a solution that is what we call citizen proof. I don't know if that's the right word for it, but essentially it means that, we need to at the same time enable efficiency, cost control, accuracy, reliability, explainability, right? And, basically building the governance that we need in order to put these things in production. I think this is really important for government applications. This is, important for everyone really, but governments are going to be held to a very high standard here. And I think this is unavoidable. So as a consequence, I'd like to spend a couple more minutes here to try and see, how we can leverage AI in government, in law enforcement, and what the kind of like the use cases would be where we might apply this, right? And then we'll go into how we can actually do this. So first of all, I think, one of the key areas of benefit for AI in government and law enforcement would be obviously an increase in efficiency and productivity. You've seen the chatbots, you've seen the LLMs in action. I can think of a bunch of use cases in government where citizens will be asking for some update on the status of an application or financials, tax returns, income benefits, whatever it might be. And, they would like to be answered in real time. They might want to have a more efficient and productive way of interacting with the government, right? Then the government at the same time would also want to do this more efficiently as well. Budgets are under pressure. How do we do this? Right. I think government can also benefit from better decision making. The predictive qualities that we see in machine learning systems are really impressive, right? And impressive in the sense that, we might actually make better predictions on usage, on, fraud cases, on whatever it might be, by using these techniques in our data sets, right? By analyzing these data sets, we can determine the patterns, right? At the end of the day, AI is really good at understanding patterns, and then using those patterns to create new insights, new predictions, right? So that's the second one, and the third one I think would be, a general set of improved citizen services. I think it's related to the increase of efficiency and productivity. That's more internally. Externally, that would translate into improved citizen services, so that every one of us, when we interact with our local or our central governments, we might be able to do that more efficiently. Overall, I think, there are a bunch of law enforcement use cases. We have seen this at Hopsworks in 2024 and before. Um, then in 2025, actually, there are specific use cases with relationship to crime prevention, understanding some of the some of the case resolution strategies. They're really, really interesting, right? If you only think of some of the summarization capabilities that we find in LLMs these days, right? That can be really useful if you're dealing with a huge volume of case material, for example. Um, I'd also like to point to the capability of reducing costs and reducing waste, that we have with AI. I think it is really good at identifying inefficiencies, preventing fraud, and that will then in itself allow us to save costs and better manage our public funds. I'd also like to highlight the fact that there's probably already quite a bit of work being done right now, but increasingly in government, in law enforcement, and in the industry at large, we're going to see a need for making sure that we do all this while ensuring data quality and governance. Right? We see that at the EU level, for example, but this is true internationally as well. We see a lot of mandates to not just implement this, on the fly and, just haphazardly, but you have to take a very structured approach here so that you can actually implement these tools in a way that complies with things like the EU AI Act or any kind of GDPR Act that might be important for you. So that's really something that I'd like to highlight. And now I would love to go into a discussion about how we at Hopsworks are trying to enable this. If you have any questions, by the way, please post them in the chat here of the webinar so that we can respond to you after the presentation. Let's go into this. So first of all, I think you will find that Hopsworks takes a really interesting approach to this. We talk about the lake house for AI, or the AI lake house. And the reason why we do that is because we have obviously built up quite a bit of expertise and experience over the years in implementing specific infrastructure for these types of processes, for AI, for machine learning. As I mentioned to you earlier, we believe that the best way for you to get to success, for you to build AI systems in a good, solid, manageable, understandable way is by, first of all, making these machine learning pipelines structured into three different pipelines. The first of which is your feature pipeline. Your feature pipeline is where you gather all the data from all your different sources. Could be structured data, could be unstructured data, could be whatever it needs to be. And you bring that together in a feature store, right? So in some kind of a data store environment where you can wrangle the data and then store it centrally. The second point is where you would want to actually use that data, use those features to train a model, right? This is your training pipeline. You train the model using your feature data so that you can actually see, okay, what are the patterns in this data set? And how can we leverage those patterns in order to do the third step, which is your inferencing. In your inferencing, that's where you would actually want to make predictions, right? During inferencing, you also want to be able to deploy this and monitor this so that you can, at the right point in time, decide whether or not you might need to retrain the model or go back to it or take some kind of action on it. This is really, really important. Right? So your input is all your data and your output is all of your predictions. And in between, what you do is your FDI pipelines, right? Your FDI pipelines are going to be um, built and deployed by different stakeholders, right? Your engineers, your data scientists, your machine learning operational engineers, and then, of course, your oversight through your architects and your governance. We believe at Hopsworks that the core of your AI lakehouse is that you bring all of these people and all of these processes together, right? The AI lakehouse is kind of like the forcing function to bring everything together and to make sure that there is a central hub where you can actually manage everything, where you can actually understand what's going on, where you can do your reporting, your all of the everything you need to do in order to have a solid system. That revolves very often around something we call a feature store. If the feature store is your uh, central repository, custom built for your machine learning pipelines, so that you can actually do all these things and bring it all together. Inside a feature store, we have multiple types of data abstractions, features, feature groups, feature views. We also have a model registry. We have all these different things so that you can actually work with that data productively. The core of a feature store is the fact that you have metadata around your data, right? Both your offline data, which is your large data sets that you use for training purposes, and your online data, which is the last data point that you're going to be used for making the last set of predictions, right? They are governed by metadata. That could be that could be uh, security information, that could be versioning information, that could be structured tags that you put onto this, all kinds of different metadata that you can actually use together. And it's the same for your online and your offline data. It's one integrated environment, right? Which makes it this forcing function from building better AI systems. The lakehouse is that forcing function. We don't want everyone to actually build their own systems, right? Without a platform like this, everyone is going to be building their own system. No, we actually want to bring it together onto a unified platform. That's what we do at Hopsworks. And I think it's important to mention, specifically for governments and specifically for law enforcement organization, that we do that on your own sovereign infrastructure. Right? Everyone thinks about AI as being something that you can only do inside, some hyperscalers environment. It's obviously not always accessible to a law enforcement organization or a government organization. But that citizen data, is not always allowed to leave the country, for example, right? Well, we allow you to manage that infrastructure wherever you want to manage it. If it's on your own custom hardware, in an air-gapped environment, or if it's at the hyperscaler, we can do everything and anything in between, right? So we want you to be sovereign. We want you to be managing that yourself, so that you can actually, at the same time get the best governance characteristics, but also, to be honest, also manage the costs because, in building an AI system can get very expensive, especially if you run it 24 by 7 on a cloud hyperscaler environment. So I'm hoping that I've given you a little bit of a view here. Um, But I'd like to recap that by saying, there's one, two, three benefits, that we offer at Hopsworks. The first of which is that we allow engineers, the technical people that build these types of systems, we allow these engineers to actually use an environment without the hassle, right? Research has shown, that engineers can spend 30, 40, and even more percents of their time, basically not doing their core job, but managing the environment. We don't want that. We want the engineer to be actually focused on their core job, on building the model, on making the predictions, and in order to do that, we want to give them an environment. We don't want them to build that environment themselves. I think most engineers think that's a tedious job anyway. So as a consequence, this is really good for the engineer. And secondly, obviously, we think that this is really good for the engineer's manager, right? The engineer's manager is actually going to do more with less, right? Because the engineer doesn't have to spend 30, 40% of their time building infrastructure, they can actually deliver more value to their organization, right? They can build more fraud detection systems. They can catch more bad guys, whatever it is that we want to achieve. But at the management level, we'll be able to get more done. And thirdly, and lastly, you know, we want to do this in a governable way. I think this is something that has, real importance, specifically in AI, when we want to have explainability in our systems, for example. But explainability starts with, knowing what's going on, having tracking information, having logging information, having, versioning information, security information. Well, that's going to be delivered by a AI lakehouse platform, you know, by default. It's the core of what it does, really. All right. I think I've spent enough time on this for now, so I'd like to proceed to quickly show you this, and I'll also summarize that a little bit later. But, first of all, I think it's really important that you also take a look at our website. If you go to hopsworks.ai, we have a really nice solutions page here, specifically for government, specifically for defense and law enforcement. We have it for other industries as well, obviously. And you will find a lot of information here. So I highly recommend that you go there. We also have a free version of Hopsworks that you can test, right? So if you go to app.hopsworks.ai, right, this is a serverless environment where you can basically, find an endpoint and start working with it. There's some, showcase projects that you will find, but you can also build your own project so that you can actually take this for a spin and try this yourself, right? You will find that there are some parts of the platform that are grayed out, specifically the compute parts. Obviously, because we're assuming that, in a testing environment, you would want to do your own compute. You would want to do that on your own hardware. However, we also have a really nice demo environment where we can actually see all of the different sandboxed projects, right? So we can provide you access to this if you really want to build some kind of a proof of concept. But in this case, you see that I have a number of projects here. A project is kind of how we sandbox a piece of functionality, and how we also have role-based access control organized. And within a project, you will find the different pieces of the AI lakehouse, right? So it starts with the data. You will see that there are data sets here, right? Different versions of that data set, right? So if I look at the transactions, right, I will see that there are multiple versions available, right, to those transactions, right? And then I can see, okay, what is the data in that feature group, right? So I here have a key, that's the transaction ID. I have a date time. This is really important for machine learning and AI because the date time in this particular case is going to be my event time. My event time is going to be what I use to do a point-in-time correct join between different data sets when I build my training data sets. It's also cool that I have provenance information here. This is quite limited for the second version, but for the first version, it's actually a little bit more elaborate, I believe. You will see that it has a graph, right, or a chain of different um, pieces to the data set that are being brought together here. You will see this more elaborately later on. We also have expectations. Expectations is like a data validation step. We have tags, right? Structured tags that you can assign to data sets. And then obviously we can preview the data set. We can calculate statistics over it. We can monitor that, right? So if, for example, a data set is a dynamic thing and it keeps refreshing, and we want to see whether it's within certain ranges, not just the data quality in itself, the validation, but also the statistics of it. And if it's beyond certain boundaries, then we want to take some kind of a step. We might want to retrain the model, for example. So that's my feature groups. For my feature views, very similar, right? So we have a list of features, and we also have where the training data sets are coming from. But here you see a little bit more of a complicated view or a lineage graph, right? You see how things are brought together. You also see that, different pieces of this feature view, which is, pure metadata, right? We bring the data together and we join it together from different feature groups, right? So you see that there's data coming from transactions feature group and from the profiles feature. Important also to mention, I forgot to mention that when I talked about the feature groups here. Feature groups can be internal or external. They can be stored inside the Hopsworks environment, or we can point to it. We can use a storage connector in order to link to it. In the compute environment, we also have the possibility to run jobs, to run scripts, to run notebooks, right? So that, if, for example, you're dealing with sensitive citizen data, the data never needs to leave the environment. It can just stay on the server infrastructure that you have assigned to this project. By the way, we also do like resource management, a scheduling of resources so that we accurately know who's using which resources. We have an airflow environment if you want to have more complex scheduling. And then finally, when we get to the inferencing pipeline, right? So we have done our feature engineering, we have done our training. We can also register a model here, and the model, it's a standard way of looking at this, where we can basically have some metrics, evaluate it. We have a schema for it. We have provenance information. We have all of these different things, and then we can deploy that. We can deploy that on the infrastructure, and then once it's deployed, you can actually ask it some questions, and you can ask it for a prediction by sending it some data. There will be an API here, an endpoint that you can send data to and then receive the prediction from, right? All of these projects that I've shown you here are publicly available, right? If you go to github.com/logicalclogs/Hopsworks tutorials, you will there see a large number of example projects that you can actually use to try this yourself. Hopefully that's giving you a little bit of a view on what we do. You can find all of these resources on our website. Go to our industry solution page, take a look at the use case descriptions, and then, find the examples that I've just mentioned, the fraud detection example, or, any other example that you might be interested in on our GitHub repo. We also have a number of videos available for you. If you do want to rewatch this particular video or another one that we did at a different point in time, please find us on YouTube as well. With that, I'm going to wrap up the presentation section of this webinar, and I'm going to hopefully reiterate that you can, in fact, also as a government organization, as a law enforcement organization, leverage the power of AI to be a more competitive organization, to be at the forefront of what we can do with machine learning and AI in your specific environment. You don't need to do this on a cloud hyperscalers environment. You can do this yourself in your environment with all the sovereignty that you would expect. I would warmly invite you to come to our community. We have a public Slack, for example. We have different ways for you to ask questions there, and we are really happy to welcome you there and to interact with you and to answer any other questions that you might have. Speaking of questions, I would like to finish this webinar by opening it up to questions. If you have anything you want to ask me, either speak up or ask your question in the Slack, in the chat. Sorry. Thank you so much. Have a wonderful day.